In finding the limit of ln of 2x squared plus 1 minus ln of x squared plus 1, if you use direct substitution, you have ln of infinity, which is infinity, minus ln of infinity, which is infinity, and it's a common mistake for students that say, hey, this is indeed is equal to 0. No, it is a common mistake that you need to avoid. In this case, infinity minus infinity is indeterminate form. So when you have indeterminate form, your goal is to simplify the quantity that you have, either using conjugate or algebra properties or any other method that helps you to simplify that quantity. From algebra, I remind myself that when I have difference between two LNs, I can combine them and write one LN. And I have ln of A minus ln of B. This can be written as ln of A divided by B. So this guy is your A. This quantity is your B. So this limit can be written as the limit of 1 ln, and the quantity is 2x squared plus 1 divided by x squared plus 1 as x goes to infinity. So this limit can be also simplified as the ln of, open parenthesis, limit of 2x squared plus 1 divided by x squared plus 1 as x goes to infinity. So intuitively, you can say that, hey, at infinity, I can ignore constant values, 1 and 1. I get 2x squared divided by x squared, which is just 2. So I end up with ln of 2. So this guy should be ln of 2. But I need to show step by step or calculus or algebra to prove this. This guy is basically the ln of, when you're taking the limit, let us divide everything by x squared. You have 2x squared divided by plus 1 divided by, long division, x squared divided by plus 1 divided by, and x goes to infinity. Let's close up the parenthesis. Down here, you divide by x squared. So this is the ln of the limit of 2 plus 1 over x squared divided by 1 plus 1 over x squared as x goes to infinity. But 1 over infinity is 0. So you end up with the ln of limit of a constant function, which is constant itself. So we end up with ln of 2. So what's the meaning of that? It means that the limit of ln of 2x squared plus 1 minus ln of x squared plus 1 as x goes to infinity is nothing but ln of 2. Limit exists, it's a unique number, and this is the limit of this quantity. So again, guys, when you're using direct substitution, infinity minus infinity is not 0. It is indeterminate form. So when you have indeterminate form, your goal is to simplify this quantity by using algebra. We could combine these ln's together and have just one ln. And this worked for us because then you end up with a quadratic expression divided by another quadratic expression that you already know how to deal with.